In this example, we're given that the average speed of a vehicle on a stretch of Route 134 between 6 a.m. and 10 a.m. is given by the function 20t plus 50 minus 40 square root t, where f of t is miles per hour, and its measurement is, and t is measured in hours, with t being 0 when it's 6 a.m. We want to find what time the traffic was moving the slowest, and we also want to find the average speed at that time. So the first thing that we have to notice here is that if we're trying to find what time the traffic was moving slowest, that means we want to minimize our rate of speed. In other words, we want to minimize the function f of t, since f of t is our miles per hour, our rate of speed. So we're going to be using the second derivative test. You could also use the first derivative test, but in this case, second derivative test will just work out much nicer. So the first thing that we have to do when we're using the second derivative test is to find the first and second derivatives of our function. So before we start that, I'm going to rewrite this function in a form that's easy to take the derivative of. We have 20t plus 50, and I'm going to change this minus 40 square root t to be minus 40 times t to the 1/2. Remember, whatever your root index is, so square root in this case, that's the denominator of your fraction. So square root means 1/2, cube root 1/3, and so on. So now we can start finding f prime of t and then f double prime of t. So to start off with, the derivative of 20t is just 20. Remember, you take your exponent, you multiply it out front, and then you subtract 1 from it. So we're just left with the 20. The derivative of 50 is just 0. And then the derivative of minus 40t to the 1/2, again, we'll multiply the exponent out front and subtract 1 from it. That gives us negative 40 times 1/2 is negative 20 times t to the negative 1/2. Now, we're just going to simplify that really quick. Not completely, though, because we still have to find another derivative. So that gives us 20 minus 20t to the negative 1/2. And now we can find the second derivative by finding the derivative of this. So we get f double prime of t is equal to the derivative of 20 is just 0. And then the derivative of negative 20t to the negative 1/2, again, we multiply the exponent out front and subtract 1 from it, which gives us positive 10 times t to the negative 3/2. And now that we have both of our derivatives, we're just going to completely simplify them before we start using them in our second derivative test. So 10t to the negative 3/2 for our second derivative. A negative exponent just means that you move the value to the denominator. So we get 10 over t to the positive 3/2. And then over here, we had 20 minus 20t to the negative 1/2. That's going to give us 20 minus 20 over t to the positive 1/2. Again, negative exponent, we had to move it down. Okay, so when we're doing the second derivative test, once we found our first and second derivative, we need to take our first derivative and find the critical numbers such that the first derivative is equal to 0. In other words, we need to set our first derivative equal to 0 and solve for t. So we get 20 minus 20 over t to the 1/2 is equal to 0. We'll go ahead and add 20 over t to the 1/2 to each side of the equation. Which leaves us with 20 equals 20 over t to the 1/2. At this point, we'll put this 20 over 1, since 20 is the same thing as 20 divided by 1. And now we have two fractions equal to each other, which allows us to cross multiply. So that's going to give us 20 times t to the 1/2 is equal to 1 times 20 is just 20. From here, we can divide each side by the 20 that's in front of our t to the 1/2, which gives us t to the 1/2 equals 1. And finally, if we want to get rid of this 1/2 power, we're going to square each side of the equation, which leaves us with t equals 1. Okay, so now that we have this t equals 1, this is a partition number. The way that we check if it's a critical number is we go back to our original function and plug it in, and we have to get a real number out of it. So we can't get division by 0 or a negative inside of a square root and so on. So we're going to bring this step up over here, and we're going to find f of 1 to make sure we get a real result. So we get 20 times 1 plus 50 minus 40 times the square root of 1. This is all coming from our original equation that we had over here. So now if we just quickly simplify this, we can use a calculator or just run through it really quickly. Either way, we'll end up getting f of 1 equals 30, which is a real number. So that means 1 is a critical number. And critical numbers are important because critical numbers are the only place that we could possibly have a maximum or minimum occur in our function. So right now we've proven that this value t equals 1 will either result in a minimum or maximum on our function f. Now we just have to check which one it is. And it's called the second derivative test because you test your critical numbers in the second derivative. So we'll take f double prime and plug this value of 1 into it. And we said f double prime is 10 over t to the 3/2, so we get 10 over 1 to the 3/2, which just ends up giving us 10. But we don't care about this number. What we care about is the fact that it is greater than 0. It's positive. And because this is positive, the second derivative tells you concavity, whether you're dealing with a concave up or concave down looking graph. So because the second derivative is positive at 1, that means that we have a concave up shape looking like this. And if you look at this picture here, it's clear that there is a minimum. So we've proven that when you plug 1 into your original function, you will get a local minimum. So now we can put all of this together to say that when you plug 1 into the original function, which is what we did here, you'll get a value of 30. That 30 represents the lowest rate of speed. So 1 comma 30 is the local min or local minimum. But now we have to put this into words because this is a story problem. So it says at what time of the morning commute is the traffic moving at the slowest rate? Well, our time is our t value. So we said t equals 1 is when it's at its slowest. And we know that when t is 0, it represents 6 a.m. So t equals 1 represents 7 a.m. Now the second part is what is the average speed at that time? That's the f of 1 value that we found, which is the 30 miles per hour. So let's put this into a sentence answer and we'll have the problem completed. So we'll say the slowest rate of speed occurred at 7 a.m. and was an average rate of 30 miles per hour. And that completely answers our original question.